we've been doing, and that's where we come to conclusions through pattern observation. Okay. Inductive reasoning is less precise than deductive reasoning. Deductive reasoning is when you use facts, definitions, properties, rules, okay, so because you're using facts, deductive reasoning is more valid or more precise than inductive reasoning. Do you remember when we were talking and I was talking about my coffee cup and I bring that coffee cup every day? Of course, I don't have it right now, but I have a coffee cup every day. And so somebody might see that I have a travel mug every day and make the induction that I drink coffee every day. But they're just observing a pattern, and the pattern is that I have this travel coffee mug. But they don't know for a fact that I'm drinking coffee every day, because what if it has coffee in it one day and it has tea in it another day, and another day it has chocolate milk or fruit juice, or they don't know. In order to make the conclusion that I drink coffee every day using deduction, they would need to see inside the cup and know for a fact that there's coffee in the cup. That would be deduction. So deduction is based on actual factual information, like cold, hard, factual things. So when we look at these two examples here, we have Katie. Every time Katie has worn her favorite socks to a softball game, she's gotten at least one hit. Katie's wearing her favorite socks to the game tonight, so she concludes she will get at least one hit. Is this based off factual information? No, right? Because the fact, yeah, it's a pattern. She's been wearing her favorite socks, she gets a hit. That's a pattern. So it's induction or inductive reasoning. But it's not a fact that her favorite socks made it so she gets a hit. So that's why it's not deduction. Does that make sense? Okay, and then for the second example, if John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month. So he concludes that he will be assessed a late fee of $50. This is deduction. Because it's a fact that you're going to be charged extra $50 if you're late. That is a fact. So if you're late, then you can conclude that you are going to be charged the $50. So does that make sense, kind of the difference between these two things? All of the signature items on the restaurant's menu are noted with a special symbol. Kevin orders a menu item that has that symbol next to it, so he concludes that his menu item is a signature item. Deductive. Because we're taking facts. Like the fact is that it's a signature item, it has a symbol. The fact is he ordered the item with the symbol, so the fact is he has the signature item. Okay, none of the students who ride Raul's bus own a car. Ebony rides a bus to school, so Raul concludes Ebony does not own a car. Now, Ebony rides a bus. Okay, this is a fact that none of the students who ride Raul's bus own a car. Well, we're going to assume it's true. But it says Ebony rides a bus to school. It doesn't say that Ebony rides Raul's bus to school. So do we know anything about the status of the people on the bus that she rode? No. So this would be inductive reasoning because we don't know if it's we don't have the information about the bus that she rode. We only know about the kids on Raul's bus. So this might be a pattern that we would observe and say, oh, well, people on the bus don't own cars. She's riding the bus, so she doesn't own a car. But we can't, that's not a deductive conclusion because it's not based on fact. It's based on personal observation. We don't know anything about what bus she was on. Maybe everybody on that bus owned cars, but they're just environmentally conscious, so they decided to ride a bus together. Valid versus invalid. Okay, if you are valid, if you have a valid argument, you're logically correct. You are proven using facts. Okay, and it's not easy to disprove. If you're invalid, a single counterexample will prove you false. Okay, so valid conclusions are based on deduction. Induction is not considered a logically valid means of coming to a conclusion because it's based on observed patterns, but observed patterns aren't always fact. Okay. The law of detachment is it's a law using deduction to come to conclusions. Okay. And what that law of detachment says is that, okay, if you remember, the arrow means if P then Q. So they're saying if the statement if P then Q is true and P is true, then Q is true. Okay, so if the whole sentence is true and the first part of it is true, the P part is true, then Q is true is the conclusion, and that is also true. So P being true forces Q to be true. Just as an example, if my car is out of gas, it won't start. Sorry, then it won't start. Okay, so this is my if P then Q statement. Do you guys agree that this is true? Like the whole statement in and of itself is true? Okay, then I say P, my car is out of gas. Okay, so if I say if my car is out of gas, then it won't start. My car is out of gas. What conclusion can we come to? Right, the car won't start. This first part of the sentence being true forces the second half of the sentence to happen. So, if my car is out of gas, then it won't start. We said that was true, we said this is true, and this forces this to be true. Okay? So we can use the law of detachment to determine whether or not a conclusion is valid. And the way this will work is it needs to stay in the same order. If two angles form a linear pair, then their non-common sides are opposite rays. This is P, this is Q. I'm going to say angle AED and AEB form a linear pair. I'm just going to draw that so we have a picture to look at. Okay, AED, AEB form a linear pair. Okay, this is P again. Two angles form a linear pair. Conclusion, ED and EB are opposite rays. This part is Q. non-common sides, ED and EB, are opposite rays. Because it went in order, PQ, PQ, this is valid. If Micah goes to the beach, P, she will wear sunscreen, Q. Micah is wearing sunscreen, that's Q. If Micah goes to the beach, she will wear sunscreen. This is P and Q. And then we said Q, she's wearing sunscreen. And then this is P. So do you see how this is out of order? It's flipped. We said P, then Q, Q, P. What we want is P, then Q, P, Q. We want them to stay in order. First, second, first, second. Because of this flipping, it's invalid. That doesn't make sense? Yeah, because here's what we can do. Okay, if Micah goes to the beach, she'll wear sunscreen. That means every time she goes to the beach, she's for sure going to wear sunscreen. And then we say she's wearing sunscreen. Okay, but does that mean she's at the beach? No. Maybe Micah's at the pool. Or the park. Or in a tanning salon. Or anywhere else that she might wear sunscreen. The beach means she wears sunscreen, but wearing sunscreen does not mean the beach. It doesn't go backwards. Does that make sense? So it has to stay in the same order. So the first part, second part, first part, and then you can conclude validly the second part. Here we have, if 3 points are non-collinear, they determine a plane. My typing on this is all kinds of messed up. Sorry about that. This is P. This is Q. Points A, B, and C lie on plane G. Is this P or Q? We've got plane and plane. So that makes this Q. And that makes this P. And so again, we're out of order. We've got P, then Q, and then Q. And then P. So it is invalid. And I can find a counterexample. Counter. Okay, I can draw plane G. And I can put A, B, and C on a line inside plane G. So if I have 3 points that are non-collinear, then they do make a plane, but just because I have 3 points in a plane doesn't make them non-collinear. It doesn't go the other direction. It has to stay first part, second part, first part, second part in order to be valid. Okay. Using Venn diagrams, we can kind of see why this picture works. If I have this universe of primates, and inside my universe of primates I have apes, and I have, actually let me take that apes off there. I have apes, and I have primates that do have tails. Okay, so if a primate is an ape that does not have a tail, right? So I have a primate and it's an ape, it doesn't have a tail, so they're not, those circles don't overlap. Okay? And if you think about apes, do you think about all the apes? You've got gorillas, you've got chimpanzees, you know, you've got, okay. Coco is a primate that does not have a tail, so she's not going to go in the tail ball. Can I conclude she's an ape, though? No, because maybe she's an ape, but couldn't she be some other kind of primate with no tail? Like a human? We're primates. We don't have tails. Maybe Coco is my best friend and we're going to go to the mall and she is very offended you thought she was an ape. You know, I mean, like, right? Just because you're a primate without a tail doesn't make you an ape. So that's why that flipping doesn't work. Okay, whereas here we have if a figure is a square, then it is a polygon. So we have the universe of the polygons, and squares lives inside of there. And if I say figure A is a square, it's automatically inside the polygon box, so it works. We went in order: square, polygon, square, polygon. Okay, so the law of syllogism is another deductive reasoning. But whereas the law of detachment, which was that first one we did, detachment, where we have PQ, PQ. The law of syllogism has a bit more to it. It's if P then Q is true, and if Q then R is true, then if P then R is true. Okay, so you can take out that middle section. Like if P goes to Q and Q goes to R, then P can go straight to R. So for an example, let's say if you get a job, then you will earn money. Okay? So this is P and this is Q, and we're saying that's true. If you get a job, then you will earn money. And then we can say if you earn money, that's an earn money, then you will buy a car. Okay? Earn money was the Q. So that stays Q. So if you get a job, then you will earn money. If you earn money, then you will buy a car. That's R. So what we can do is we can take out that double Q and just turn this into if you get a job, then you will buy a car. Okay, and so what this looks like is if I take P goes to Q and Q goes to R, I can cross out the Q's and like kind of do a Z and just go straight from P to R. Like this. If I, let's say I need 20 quarters, but I have a $5 bill. So here's my $5 bill. And Brian, you don't have 20 quarters, but you do have 5 ones. Okay? And Amanda, you have 20 quarters, but you don't want a $5 bill, you want $1 bills. I can take my $5 bill, go to Brian and get 5 ones, then go to Amanda and take my 5 ones and give her the 5 ones and get the 20 quarters. So I'm going from my $5 bill to my 20 quarters with these 5 ones in between. But the end result is I went straight from the $5 bill to the 20 quarters. Does that make sense? So the Q becomes the bridge between the first part and the second part, or the last part. So you can get rid of it. We don't need to talk about it, because then if I were going to, like I needed those 20 quarters when I had the quarters to go do laundry or something, somebody's going to say, oh, you've got change, and I'm just going to say, yeah. Right? Then I'm going to, well, first I had to go to Brian and get 5 ones, then I had to take those 5 ones, go to Amanda and get, nobody cares. Yes, I got change. We're done. Right? So when we look at these to determine if we are logically valid, if we have used the law of syllogism, I have to go PQ, QP. In this example, I have PQ and then RQ. See how these don't match? So I can't take out that middleman, and if that's the case, there is no valid conclusion. It has to be 1, 2, 2, 3. And the 2's in the middle and come out and you go straight to 3, from 1 to 3. Okay. Questions on that so far? So if we look at this one, if you do not get enough sleep, then you will be tired. So that's P and that's Q. If you are tired, that's Q, then you will not do well on the test. That's R. So we have our PQ and QR, and we want to create that bridge and go straight from P to R. So my P is if you do not get enough sleep, and my R is you will not do well on the test. So here's my valid conclusion. If you do not get enough sleep, you will not do well on the test. We're going to look at some statements, and we're going to come up with a valid conclusion. So if you are 16 years old, then you can apply for a driver's license. Nate is 16 years old. Here's P, Q, P. So what is my valid conclusion? Yeah, Nate will apply for a driver's license. Okay. The midpoint divides a segment into two congruent segments. So midpoint is P, congruent segments is Q. If two segments are congruent, there's Q again, then their measures are equal. That's R. M is the midpoint of AB. This is P, which will lead me to Q, which is that AM is congruent to MB, right? Midpoint divides into two congruent segments. So what is my valid conclusion? Looking for R. Oh, oops, sorry. That was wrong. Okay. Yeah, the measures are equal. That's my conclusion. So I go from yeah, congruent talks about like when you say two figures are congruent, they have all the same measures, but basically you're saying that the shapes are the same, like the actual physical pieces are the same. And then when you take the bars off the top and put the equal sign in it, you're saying that the lengths are the same. So it's like saying 5 is equal to 5. Whereas here, that's like saying this piece of stick is equal to this piece of stick. It's a technicality. They're basically equivalent ideas. Okay, so why don't we look at these last 4 questions on the practice and see how we do on those. So you're going to look at these and see if you can come up with a valid conclusion. And you're using syllogism, so it's PQQR, and come up with a conclusion. And then if you can't come up with a conclusion, you say no valid conclusion.